Now, let us discuss in a matrix how to represent a cell using a single integer. Let's say the R cross C matrix, the number of rows are 3 and the number of columns are 5. So, overall, how many cells will be there? 3 into 5 is equal to 15 cells will be there. Let us have an example. So, 3 rows and 5 columns, 5, 7, 10, 11, 15. And then we have 8, 10, 12, 14, 20. So 21, 30, 35, 40, 50. So let us write the index values for these columns. So index values are 0, 1, 2, 3, 4. And the index values for the row are 0, 1, 2. So now what we should do is we should represent these index values, okay, row index and column index using a single integer. So let's take 10. So 10 row index is 1, for 10 row index is 1 and col index is 1. For 40, okay, for 40 row index is 2 and the col index is 3. So how to represent them using a single integer? We can do it like this. So let's say there are 15 values here, 3 into 5. So we have to assign the index from 0 to 14. That is what we need to do. So if we are going to assign such values, so 5 will be 0, 7, 1, 2, 3, 4, and this must come as 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now to convert this, okay, to convert these index values, in a row we know 5 values will be there, okay. So whatever the row index is given, let's say the row index is row and the col index is col, the formula to convert is the row index into C. C is the total number of columns plus col. So let's do for 10. So what is row index 1? 1 into C. What is C? It is 5. Plus col. What is col here? 1. So it is 6. So you can see 10 is mapped to 6. Let's do it for 40. So it is 2. Row index is 2 into capital C. It is 5 columns are there. Plus the col index. Okay, 3. So it is 13. So for 40 you can see 13 is mapped. Now you have represented as this single integer. So how to get the reverse? It is simple. See here you are multiplying, right? So the inverse process is division. So whatever the single value, we get single value by C. So here you are adding it. Okay. So whatever to your product you are adding it, that product if you want to find, you have to take modulo. Okay. You have to take modulo. So single value modulo. So let's take any cell. Let's take 20. Okay. 20, what is the value? 9. So to get the row index, okay, it is 9 by C, 5. It is integer arithmetic. So row index will be 1. Because 9 by 5, you should not say 1 point something. It is row index is equal to 1. For col index, it is modulo. 9 modulo 5. So col index is equal to 9 modulo 5. Remainder is 4. 4. You can see 20 is 1, 4. So this will be useful in certain places where we need to represent the row index and col index as a single integer value. It may be useful for you to sort based on a single integer rather than based on two values, row index and column index. So in that case, you can use it. So let us consider one more example, 30. So for that, the single integer value is 11. So 11 by C, it is equal to 2. So row index is equal to 2. And column index is 11 modulo 5. Remainder is 1. So you can see 2, 1. Okay, row index is 2 and col is 1. You can see that 2, 1. So this is a formula to use. So to summarize, given R and C are the matrix size, given the row index and the call index, to convert to single value, okay, you have to use the formula row into C plus call, okay, to get the single value. So from the single value to get row call, okay, you have to use single value by C and single value modulo C. So these are the two things we need to do. So please keep this in mind and solve a program using this. Thanks a lot for watching.